All right, so we're now going to jump into sections 1.4 and 1.5, which taken together is just the study of a concept known as slope. Let's actually start to build here. So take a look at the following graph. Now, what we know is a line is going to have the same slope throughout the entirety of the line. Just like if you could think of it, well, I won't try to draw an analogy, but the idea is simple enough: is if you know the slope here, then you know the slope here, and you know the slope here, and you know the slope of every point. So if you know the slope of one point, or I should say, if you know the slope of the line at one point, then you know the slope of the line at every point. But what are we trying to say when we say slope? Well, the idea is pretty straightforward. What I have done for you is I've just arbitrarily chose 2 points on this line. Now, I don't know what these points are, so what I'm going to do is I'm going to say, well, let's just assume that this first point, we know it has some x value and some y value. But since I don't know what they are, I'm just going to say that this point resides at x sub 1, y sub 1. Likewise, I don't know the location of this other point either. But I know it too has an x and a y value. It's definitely not the same as the first point. So we'll just say that this point resides at x sub 2, y sub 2. And now, what are we saying? What are we trying to discuss when we talk about the slope between 2 points? Well, this is what we're trying to say. So you can imagine, to get from the first point to the second point, there's a change in the horizontal distance, right? And there's a change in the vertical distance. And here's what we're really trying to say. We're trying to say for every unit change in the horizontal distance, how much does the vertical distance change? Let me see if I can state it this way. Well, we refer to that horizontal change. That's just, I'm going to use a triangle, which just means it's delta, which means change. And this would be the change in x, right? Don't you agree with me that if you were standing here and you started walking and then you stopped right here, you're not at the same x place you started, right? You definitely traveled along the x-axis. And if you want to know how far you traveled, well, that's the change in x. Likewise, if you were to start at this point and travel to this point, wouldn't you agree that you have to go, the y value has to change, right? The y value is increasing in this case. So this is what we call the change in y. Now, the slope is just a fraction. It's just a ratio. It's the change in y divided by the change in x. Now, some of you may have learned this as rise over run, but the rise is this part. How much did y change? And the run is this part. How much did the x change? So rise over run. What does that mean? Well, let's see if we can get to this part right here. So back to what I was saying. If you were standing here and then you walked to this new location of x, how would you figure out how far you walked? Well, the easiest way to do it is to take the place, the x value where you are now, then subtract the x value where you started, x sub 2 minus x sub 1, and that'll tell you how far you traveled. I mean, that makes sense. I mean, seriously, like if you walk from one side of the room to the other side of the room, if you say that if you started at 0 and then you walked to the other side of the room, and that's 15 feet away, well, if you do 15 minus 0, that would tell you how far you traveled, right? The x sub 2 minus x sub 1. Same thing here. If you want to know the change in y, it's going to be the second y value minus the first y value. So that gets us to our definition. So the slope is simply a second y value minus the first y value divided by a second x value minus the first x value. That's it. That is your change. That is your slope. That's your rise over run, if you will. Okay. What does it measure? Well, it measures the steepness. That's what a slope measures. If you ever, if you like to go, let's say if you like to go backpacking, and say you're traveling, well, there's some great places out through West Virginia. And what you'll notice when you're traveling out to some of these locations, you'll find some really, really steep roads. And you'll see signs, right? And in other words, like you'll see a sign on the side of the road that'll say something like 13% grade. And do you know that sign that you see is actually trying to tell you the slope of the road that you're on? So 13%, the way you would understand that is, well, any percent means something divided by 100. So 13% means 13 divided by 100. So when you see that sign on the road that says 13% grade, what that's trying to tell you is for every 100 feet you travel on the road, you could expect a rise of 13 feet. Right? So for every run of, let's say, 100 feet, you would expect a rise of 13 feet. And that's trying to tell you the steepness that you're going up. And that is pretty steep, by the way. You could, or if you're going up or down, the slopes could be negative or positive. But what do we want to do now? So no more theory. Let's just jump in and try a problem. So all that you're asked for this question is, can you find the slope if you're given 2 points on a line? So how do we proceed? Well, first we have to have access to our slope formula. Many of you have this memorized. And if you do, that's wonderful. If not, it's okay, as long as you have access to it. Ready? So this part right here, we're going to start to label. So we're going to label x1, y1, x2, y2. Ready? Let's go. So this is going to be, this will be x sub 1, this will be y sub 1, then this can be x sub 2, and this will be y sub 2. And now all we're going to do is take these numbers, right? And plug them in. We're going to plug them into the right spot. So this 4 is going to go here for y sub 2, and this -1 is going to go here for y sub 1. Now I'm going to finish this question, and then I'm going to answer a question you might already have. And the question you might already have is, well, how did you know to label these x1, y1 and label these x2, y2? So let's first answer the question, and then I will come back to that inquiry. Ready? All I'm going to do right now is plug in. So y sub 2, we should have a 4. Now there's already a minus symbol there, right? Y sub 2 minus y sub 1. What is y sub 1? Y sub 1 is -1. Okay, so that's going to be divided by, now x sub 2 is -2, and that's going to be minus, and what is x sub 1? Well, x sub 1 is -3. So what do we get? Well, 4 minus -1, that minus -1, that would be, that double negative. That's like if your parents were to tell you you cannot not go to bed, right? That's a contradiction, right? That's a negation. You cannot not go to sleep. Well, that means, that negation changes, right? It changes what they're saying. So 4 minus a -1 is just 4 plus 1. All right, so now we have -2. There's that double negative again, so minus -3, so that's just plus 3. So the result is 5 divided by, well, 3 combined with -2 is 1. All right, so this is your slope. Normally you would just write that 5 divided by 1 is just 5. So normally you would write it like this, but nevertheless, that is the gist. That is how you find your slope. Now let me answer that question. How did I know to call this point x1, y1 and call this point x2, y2? And let me say it doesn't matter. It doesn't matter. I could have called this point x1, y1, and I could have called this point x2, y2. You would have got the same answer. The only thing you can't do, right? Watch. I can call this x1, y1, or I can call this x2, y2. Doesn't matter. What I can't do is this. I can't do this. I can't call this x1, y2. I can't mix them up like that. But nevertheless, it doesn't matter what you call the first point or the second point. All right, I'm going to go ahead and you're welcome to pause the video if you'd like. I'm not going to take my time with this one. I'm just going to jump right to the answer. So let's do x1, y1. Hopefully that shows up okay on your end. x2, y2. Reach out to me if shoot me an email if, for example, like if when I use this color on this background, if you don't see it very well on your end, please let me know. Shoot me an email. Anyway, let's go ahead and plug in, and that's going to end up being -2 minus 4 divided by 2 minus -3, which is, we got -6 over 5. So there we go, -6/5. So we have a positive slope and a negative slope. Ready? Now what is the difference between a positive slope and a negative slope? Let's go ahead, let's go to the next page. So what you're seeing here is the graphs of some different types of slopes. Now again, notice what we have to read left to right, okay? So if you have a positive slope, if your slope is greater than 0, like this, 5 is greater than 0, then what you can expect is that your graph will be increasing. If you have a negative slope, like the part B of that last problem, then what you can expect is that your graph will be decreasing. Now we're going to come back to these two ideas, but it's possible that you have no slope at all, right? Like if you were to jump on a treadmill and, it might start on a flat surface. And then sometimes you can start hitting the button that inclines it to make it a harder run, if you'd like. But when you start out, it's on a flat surface, meaning it has a 0 slope. So if m equals 0, if slope equals 0, then this is what your line looks like. It looks like a horizontal line. It's also possible that your slope is undefined. And we're going to come back to this idea in just a second. But if it is undefined, then you would expect to have a graph that is completely vertical. All right, well, where do we go from here? So at this point, if I give you 2 points, you can find me a slope. But what if I only give you 1 point? Or what if I give you or actually, let me phrase it this way. What if you're not happy? What if you're not satisfied with just knowing the slope? Right? In other words, just knowing 5 is not good enough for you. What if you want, here's this line here, what if you want the equation of that whole line? Well, knowing the slope is important if you want to find the equation of that line. But where do we go from here? So let me write something. So if m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, then let me go ahead and talk to you a little bit about what we call the point slope form of an equation. Well, first off, can you agree? Look how similar these guys look. Maybe no one's ever showed you this. Don't they look they look pretty similar to me. In fact, if you just multiply both sides of this equation by this denominator, right? This denominator would move right here. That's exactly what you would have, is a point slope form. So from the slope, you can get to a point slope form. Well, what is this used for? Well, mathematicians we might overly define things, and we might have, arguments and hold entire conferences over a single word in a definition. But nevertheless, this is a pretty good and fairly straightforward title. A point slope equation is an equation you would use if you have a point and a slope. That's simple. If you have both of these pieces, 1 point, 1 slope, then you can plug right into this equation. Now, I'm going to start this process, and then I'll tell you where we go from here. Okay? So let me read example 2. It says, write an equation, now in point slope form. So they want it to look like this. For the line with a slope of 4 that passes through this point. All right, let's take some notes, right? So we're told that m, the slope, is equal to 4. And we're told that we have a point on that line, -1, 3. So what do you know? Here, the only thing you know about this line is it crosses this point, and that this is the rate of change. Ready? Let's go ahead and see if we can use this point slope formula. So y minus y sub 1 equals m times x minus x sub 1. Now, the book uses the notation y and x. But in due honesty, I like this y sub 2 minus y sub 1, x sub 2 minus x sub 1. So if you don't mind, I'm going to go ahead and write this as y sub 2, x sub 2. That way it looks exactly like what we started with here. So, and this is going to be y sub 2, x sub 2. Same thing. It's just preference. Okay, well, let's go. All we need to do is start plugging in some things. So we know to plug the 4 in for the m. That's easy. But wait a minute. Where do we put this point? Right? So this, if x is negative 1, do we put that x in here or do we put it in here? If y is 3, does that mean we put the 3 here or do we put it here? So, long story short, this is important. The point that you're given, since you're only given one of them, we're going to call this x1, y1. Now, so that's important. And now all I'm going to do is draw you some arrows. Ready? So 4 goes here. 3 goes here. And negative 1 goes here. Let's do it. So what's left? Well, that's y sub 2 minus, well, what is y sub 1? It's just 3. And that's going to be equal to m, which is 4, multiplied by x sub 2 minus x sub 1. And what is x sub 1? Well, x sub 1 is negative 1. Okay, so let's clean this up. So y minus 3 is equal to, so we got to turn this into a plus symbol, and we also got to distribute that 4. So that's 4 times x plus 4. Okay, so our job is done at this point. This is what we call the point slope form of the line. And that looks exactly like the definition above. There's a second part of this question right here. Let me get rid of these arrows. The second part of this question says, after you're done with the point slope form, solve it for y. So, but this is really easy. Once you get to here, I can get y by itself. I'll just add 3 here, and then I'll solve, and we would have solved for y. So if I add 3, I now have y is equal to 4x plus 7. Okay, so this is the point slope form. I'm going to give this form a name in just a second. But before I do that, let's jump to example 3. So it says write an equation in point slope form. Okay, so we want it to look like this. For the line that passes through the following 2 points. Wait a minute. Now, how are we going to do that? So maybe you're saying, Professor, I was okay. If you give me a slope and you give me a point, I'll plug everything in, and I'm good to go. But you're saying, Professor, you gave me 2 points, but you didn't give me the slope. But don't you know how to get a slope from 2 points? Yeah, I'm right. That's exactly what we did in the very first part of this video. So first things first, for this problem, I'll go ahead and label. Let me label x sub 1, y sub 1, x sub 2, y sub 2. Let's go ahead and find the slope. So y sub 2 minus y sub 1, so that's going to be 6 minus what? Minus negative 3 over x sub 2 minus x sub 1. So we end up with, well, what do we end up with? We got 6 plus 3, so that ends up being 9. And then we got negative 2 minus 4, which is negative 6. Well, 9/6 can reduce to negative 3/2. All right, 3 goes into 9, 3 goes into 6. Ready? Now let's go back to the question. So you want point slope form. You need a slope. Do you have a slope? Yes. Do you have a point? Yes. We actually have 2 of them. So let's just use the first one. We'll use the one that we called x1, y1. All right, so here we go. It's just time to plug in. And let's go. So that's going to be y sub 2 minus y sub 1, which is negative 3. It's going to be equal to, m is negative 3 over 2. And that's going to be x sub 2 minus, and what is x sub 1? 4. Okay, so ready? Let's go ahead and clean this up. So we got a double negative here, so that's going to just be y plus 3. And if you take, we got to distribute here, so that's going to be negative 3 over 2x. And then if you take negative 3/2 times negative 4, what do you end up with? Well, you end up with, negative times a negative, so you know it's going to be a positive. And then that's just 3 times 4 divided by 2. So 3 times 4 is 12, and 12 divided by 2 is 6. So there you go. So that's the point slope form. The second part of this question says, then solve for y, which means we minus 3 here, minus 3 here. I'll go ahead and just write that. So that would end up being y equals negative 3/2 x. And if you take away 3 from 6, you have 3 left. Okay, so let me guess that your energy levels are starting to deplete a little bit, and we're kind of running up on a break. So let's take a break, but before we just before we go off, let me kind of preface what we're going to do when we come back in the next video. So I want to give a name to the equations that are solved for y. And then I want to start to talk about the slopes of horizontal and vertical lines. Okay, so I will see you I'll see you in the next video.